Hello, welcome back to Educator.com and welcome back to physical chemistry. So in the previous lesson, we discussed entropy as a function of temperature and volume. In this lesson, we're going to do the same thing, and we're going to discuss entropy as a function of temperature and pressure. So let's get started. Okay, so let's take entropy as a function of temperature and pressure. And let's write our total differential expression, which is going to be ds is equal to ds dt at constant pressure plus ds dp at constant temperature. This is going to be times dt, and this is going to be times dp. Now, let's recall the fundamental equation. The fundamental equation is ds equals 1 over t du plus p over t dv. Let's recall the definition of enthalpy. Enthalpy is H equals U plus PV. Therefore, I'll go ahead and move this around, and it becomes U equals H minus PV. Therefore, the differential du equals dH. So we have this u equals h minus PV. Now I'm going to differentiate this expression. So I get du equals dH. Well, when I differentiate this is a product, so it's going to be product rule. So it's going to be minus PdV minus VdP. Okay? Now, I'm going to put this expression for du into the fundamental equation. So I'm going to put this for that, and I'm going to end up with the following. I'm going to end up with ds is equal to 1 over t times dH minus PdV minus VdP plus p over t dv. I'm going to multiply it out. ds equals dH over t minus p over t dv minus v over t dp plus p over t dv minus p over t dv plus p over t dv. These terms cancel, and I'm left with ds is equal to dH over t minus v over t dp. Okay? So I have this. So this is just another version of the fundamental equation, just manipulated with respect to enthalpy and energy. So U is here. U also shows up in the definition of enthalpy. So this is just the version of the fundamental equation of thermodynamics involving enthalpy instead of energy. This one. This is the fundamental equation of thermodynamics. Okay? This is just the enthalpy version of it. That's all. Okay. There we go. In other words, it expresses the change in entropy in terms of the change in enthalpy and the change in pressure. Now, from our discussion of energy, we had the following. It was the constant pressure version of the du. So let me go ahead and do this in red. I had du, actually not du, it was dH. We had dH is equal to Cp dt plus dH dP under constant T dP. Let me go back to black. Now, I have this dH is this one, so I'm going to end up putting this expression where I see dH in this expression, and we get the following. We get ds is equal to 1 over t times Cp dt plus dH dP constant T dP minus v over t dp. I get ds equals cp over t dt plus dh dpt dp minus v over t dp. dp and dp, I'm going to combine some terms here. So when I do that, I end up with the following. I end up with ds is equal to cp over t dt plus 1 over t times dh dp t minus v dp.